I'm Chris Petty, and this is the Petty Test. Hey everyone, I hope you're doing well, and thanks for tuning in again. Hopefully you've been enjoying the series. So this next topic actually has come in a number of times. A number of different people have sent me track examples of what I like to call transitional sounds, ear candy types of sounds, and there's a ton of examples that I can use with this. Basically, this ranges from anything from white noise sweeps to risers to bubbling, gurgling, churning types of sound effects. And like I said, there's a ton of examples that I could actually use for this, but one of my favorites is actually a scuba track called Out There. And it has this 16-bar intro that's pretty much what I would consider to be the textbook definition of ear candy type sound. So I'm going to play the track. I actually have it pulled up here in Logic. I'm going to do the example in Logic this time. Basically, the bottom line is that these are concepts that I'm showing you, and it really doesn't make a difference what DAW you're using as long as you know the concepts and you know how to recreate this. So I'm going to hit play, and we're going to listen to the intro to this so that we can identify this particular sound.
You're going out there to destroy them, right?
So as you can hear, pretty much the entire intro, aside from one synth part here, is comprised of what I like to call a bubbling, gurgling, churning white noise modification of a sweep. So basically what I'm going to do is I'm going to recreate this with one of my favorite VST audio unit plugins, Silent One. And I actually have it pulled up here on the second track inside Logic, and I'm going to just pull up the interface, and it is running in 32-bit mode, so Logic has the 32-bit bridge. This is actually a sound based off of white noise. So what I'm going to do is I'm going to switch my first oscillator to a white noise tone. So if I strike the key now, what we'll hear is we'll hear a white noise. And it doesn't really matter what key I strike on the keyboard because white noise is not pitched. So it doesn't really sound like the sound. Let's take a listen again, and what I'm going to do is I'm going to put it in a loop here so that we only have the intro of this tune cycled. I'm also going to enlarge it a little bit so that we can see the full 16 bars. And what we're really going to do is we're going to focus in on the first 8 bars here because there's actually a little trick going on with this that we're going to look at how to recreate in a couple minutes.
You're going out there to destroy them.
So the sound almost has characteristics of a laser zap, if you want to equate it to something else that you might have heard already. It's got a very downward kind of motion to it as far as the way that the movement is on the sound. So what's actually recreating this? Well, this is a combination of the filter being controlled by the LFO, but there's also some other things going on with it. So what I'm going to do is I'm going to engage a low-pass filter onto my white noise here. And if I strike the key, you'll hear that the sound now is going to sound a little bit muffled because the low-pass filter is cutting off some of the top frequencies. What I'm going to do is I'm also going to set this to a 12 decibel filter so that's a little bit more subtle and that we'll hear some of the nuances and changes when I make it. And I'm also going to increase the resonance a little bit. Okay, so that's a good starting point. So as I said, what we need to do is we need to plug an LFO in to control the filter. This is what's actually going on. So I'm going to go down to the bottom modulation matrix area for LFO1, and I'm going to set it to control filter cutoff for A. I don't really need to have a complex synth patch going on here, so really I'm probably just going to use about one oscillator to do this particular thing, and the one oscillator is in fact generating the white noise. So now that I've got this applied, I'm going to apply an amount from LFO1, and I'm also going to turn the gain up as well. So now when I strike the key, and let me just pull my rate up just a little bit, we should hear the filter pulsating. So hopefully everybody gets the concept so far. So as I had said, it has very much of a laser zap downward motion kind of sound to it. So what I'm going to do is I'm going to peruse through some of the additional waveforms that are here inside Sylenth, and I'm going to go to the saw wave. It's actually a downward saw when it's running in positive polarity. So when I strike the key now, we should hear a downward motion that happens from this. What I'm actually doing is I'm changing my rate of the LFO right now. So there are ways to actually control this. I could draw this in. I could also try to automate it from the actual internal synthesizer structure. And this is actually what I'm going to do. So basically, if we listen back one more time to the original tune, we'll hear that it goes from a fast to a slow rate.
You're going out there to destroy them, right?
Okay, so basically what I'm going to do is I'm actually going to draw in a MIDI clip into Logic. And what I'm going to do with it is I'm actually going to extend it out over the first 8 bars. And what I'm going to do is I'm going to go inside it, and I'm going to simply draw in a single note that sustains for the entire length of the actual clip. So let's just do this at C3, and what I'm going to do is I'm going to extend the note out so that it sustains all the way through the entire 8-bar cycle. So now, if I play it back, we'll just solo out Sylenth 1. So nothing really too exciting there because we don't have any movement going on with it. So as I said, it's all about the LFO rate that needs to be changed in order to bring the sound to life. So what I'm going to do is I'm actually going to go to one of my mod envelopes, which is kind of like an auxiliary envelope inside Sylenth that allows me to plug into any parameter inside the system. And one of the parameters that I can plug into is LFO rate, and I can control this for each of the oscillators independently. So what I'm going to do is I'm going to pull my decay time up with this, and I'm also going to increase the amount. And if I trigger this from the keys, and what I actually want to do is slow down the ending rate for this. So I'm going to pull my rate down just a little bit. I may have to increase the amount of LFO rate that's applied to the envelope. Okay, so it's starting to sound pretty similar to what I have going on. What I'm going to do is I'm just going to play the clip back once now while the track is solo, just so that we can hear how it behaves over the 8-bar phrase. Okay, so it's starting to get close. I might want to monkey around just a little bit more with the actual decay time on the envelope, just so that it slows down just a little bit faster. So let's just pull it down a hair, and let's play this back again. Okay, so as I had said, this is obviously a parameter that I could draw in. I always have a fun time trying to make the synthesizer behave the way that I'm hearing the sound without actually having to draw in any physical animation. That way when I pull the patch up, if I save the patch, it plays it back exactly the same way that the sound was originally intended. So now that I've got things happening here, let's take a quick listen to the original track once more just so that we can hear what's going on here. If I play it back, basically what I want you to do is listen to it almost in two segments here. Listen to the first 8 bars and then listen what happens to the second 8 bars.
You're going out there to destroy them, right?
So, in case you missed it, the big trick with this particular sound and what's going on here is that it's actually the same sound that you're hearing twice. You're hearing it the second time backwards. That's why it has sort of an upward saw kind of motion to it instead of the downward laser kind of sound to it. So this is actually a trick of digital audio, and this actually leads us to another point as far as how we would store and how we would organize these types of sounds. Generally, the rule that I tell people is that for these types of sounds, you want to think about 8-bar blocks or 8-bar phrases. And generally, these are types of sounds that you want to keep as digital audio, and there's a couple of reasons for why you'd want to keep it as digital audio. First thing, I think it's easier to actually see the visual representation of the waveform of what's happening to the sound over time. Number two, as you can hear with this sound, the second half of this intro is a reversed version of the first one, and this is not something we're going to be able to do while the synthesizer is running in real time, simply because we can't reverse the sound output out of it. But once we have it printed as digital audio, we can absolutely reverse, twist, and manipulate however we want. And probably the most important reason for why I suggest to print this as digital audio is that because these are not the types of sounds that you're going to want to create every time you sit down to write music. You're pretty much going to want an arsenal and a library of these types of sounds that you can just mix and match and drop onto the appropriate sections of tunes that you're working on. This also fits into another very, very important thing, that you may not always write necessarily in the same exact BPM or tempo. So if you have it as digital audio, all the changes will happen in the right point if you've constructed the sound properly to change over the tempo that you're working in. And then when you stretch it to whatever the tempo is that you're working on in another project, it automatically adheres and fits to that particular tempo with all the changes and the apexes and the rises in the right points. So Logic has this really, really cool function called bounce in place, and this basically allows me to highlight any MIDI clip or object inside the arrangement view, and this constitutes for audio tracks as well. So if I have audio tracks that are loaded in with a bunch of different plugins and I'm taxing the CPU to the point that I might not be able to do too much more, this is a very, very handy feature. And although all of the programs pretty much allow you to do bounces internally, I kind of find the hotkey command inside Logic to be one of the fastest ways to do this particular type of function. So what I'm doing is I'm highlighting the MIDI clip right now, and what I'm going to do is I'm going to hold down the control button and I'm going to hit B, and it's going to bring up a dialog box that's going to ask me what I want to name the printed piece of audio, whether I want to put it on a new track or if I have a selected track inside my project file that I want to put it on, if I want to mute, delete, or leave the original, which is the MIDI clip. So what I'm doing is I'm going to select mute. And if I am running effects on it, it even allows me to track the trail. So let's say I have a reverb or a delay going on that extends a little bit longer than the clip. Well, this actually allows it to be printed and the clip will be extended for the sake of the actual trails that are coming off of the spatial effect. So I'm just going to quickly name this Bubble Forward. And I'm going to say OK. And voila, it has just printed the actual audio clip into my project file. I'm just going to shrink the view up a little bit now. We don't need to see so much. And if I solo out what I had printed here, we're going to hear. Okay, so one of the other things too that you'll notice about the original sound is there is some processing going on. There's delays and there might be some additional things to add a little bit more metallic characteristic and all this. Generally, these types of sounds I want to keep in my library dry. Any of the processing that I'm going to do, I'm going to apply to the audio. And the problem again is because there may be trails, there may be some things going on that are going to make it sound unnatural if the delay or the reverb is actually recorded into the clip. So what I'm going to do is I'm going to bounce in place this part one more time, and I'm going to call it Bubble Backwards. and I'm going to put it on a new track. I'm going to leave the original one because the original one is the bounced piece of audio already, and I'm going to say OK. And now it has printed an identical duplicate piece of it. I'm simply going to take the second one and move it over to the second half of the 16-bar phrase. And what I'm going to do is I'm going to go into my sample editor inside Logic, and I'm simply going to take this single clip, and I'm going to go to my Functions menu, and I'm going to hit Reverse. And what it's going to do is it's going to reverse it. So now, if I take a look at the arrangement, and I'm going to solo out both of these parts now, so basically the forward version of this and the backwards version. Really interesting when you line the two up, the backwards and forwards, how it really kind of blends together and seems like one seamless piece of audio. So that's basically the long and short of how you would do this. I'm basically going to put this onto first track also, and now I'm going to do a little bit of additional processing as well. Let me go here and take one of the delays from Logic. I'm actually going to take the Delay Designer and choose some sort of fancy delay here. Let me just choose from one of the presets, and let's actually do the dotted basic pan. And now if we play the sound back, we may have to balance some of the wet-dry mix. So finally, once I've got everything set the way that I want it to, what I'm going to do is I'm actually going to bypass the delay that I just put on. And what I'm going to do is I'm going to take this region right here, and I'm going to merge these two pieces together to create a new piece. So I'm going to go to the Bounce and Merge, and I'm going to say Merge. Now it creates one single piece of this audio. This is now a 16-bar phrase. And for organizational purposes, to be able to recall this later, what I'm simply going to do is I'm going to right-click on it, and I'm going to say Export as an audio file. And this is then going to allow me to export it to any location that I want. I'm actually going to save it to my desktop. Forward, backwards. And I'm going to do it to 24-bit AIF and say OK. And now the file has been successfully exported, and I can recall it. I can actually use it in any program that I like. So basically the idea with these types of sounds is that you don't want to necessarily create these every single time that you sit down to write a piece of music. You want to have a whole library and arsenal of these on hand. So the idea is to come up with something good and then create variations on it. What would some of the immediate variations be as far as what you could do to this particular type of sound? Well, if I was to look at this again, and just off the top of my head, probably the single biggest variation that would change the tonality of the sound, change the quality of it, is actually changing what the waveform is that is controlling the filter frequency by LFO1. So if I was to do a simple thing here, like just change it to one of the other waveforms, let's change it to a square wave. And let's just play this back one more time now. Let's unmute the clip, and let's hear it, what it sounds like with a different waveform. So as you can hear, it no longer has that downward laser zapping kind of sound. It's a square wave. So hopefully this has been informative for you and has helped you in some way if you've ever wondered how to make these types of transitional, what I like to call ear candy types of sounds. So remember, the concepts still sound the same. It doesn't matter which of the DAWs you're using, whether it be Live, Logic, or Reason, the concepts are still the same as far as getting a synthesizer to be able to do this. And remember, the idea is that you do want to keep these printed as digital audio so that they're on hand, because you definitely don't want to be creating these each time you sit down to create a track. For more tutorials, more infinite knowledge, please don't forget to check out dubspot.com, and thank you everybody for tuning in once again. Take care.
Welcome to Dubspot. We believe in providing you hands-on experience right away. Whether you're completely new to music and want to turn the sounds in your head into a musical reality, or you're an experienced artist looking to refine your skills and add new tools to your arsenal, we're ready to meet you at your level. For students of all ages, all levels, and all styles of music, Dubspot is here to help you achieve your goals. With course offerings both online wherever you are and at our school in the heart of New York City, we are ready to guide you through the next phase of your musical transformation. Whether you want to produce music, DJ, or do both, you've come to the right place. Come explore Dubspot for yourself. Become a part of our community and make music.